highlight in the middle of the page there the division property for radicals. Just like multiplying radicals, we discovered was a normal thing like we're used to multiplying. You can multiply a square root times a square root and get an answer inside of a square root. The same is true for division. We already found out that adding and subtracting does not work this way. But multiplying and dividing does work for radicals. So if you had something that was like this, that you wouldn't know. Does anybody know what the square root? Whoa. Do we know what the square root of 27 is to 25 decimal places? Okay. Do you know what the square root of 3 is to 25 decimal places? No. But the square root of 27 divided by the square root of 3 using the division property is the same thing as the square root of 27 divided by 3, which is kind of helpful because you can simplify that. 27 divided by 3 is just 9. And do you know the square root of 9 to 25 decimal places? Yes. It's 3. Perfect. So sometimes we might have numbers that we can't evaluate in our heads, but if we use the properties and saying, in this case, I can divide them, then it helps us simplify. And this is true as long as, right, you could do this with cube roots. For example, the cube root of 16 divided by the cube root of 2 would equal the cube root of 16 divided by 2, which is the cube root of 8, which is just 2. So one of the things I talked about earlier that we're going to do lots of is changing things from entire radicals to mixed radicals and mixed radicals to entire radicals. Changing something to a mixed radical, you know what? Actually, before we do this question, I'm going to get you at the top of this page, write the following. This is going to help us in our mental method. And we're going to put exponents up here and bases here. And we're going to have a base of 2, 3, 4, 5, 6, 7, 8, 9. And we're going to have an exponent of 2, 3, 4, 5, 6. So hopefully you can make it tiny enough across the top that you can fit those numbers. We're not going to fill in all of these boxes. So what this means is if I have a base of 2 and an exponent of 2, it's equal to 4. The second one is a base of 2 and an exponent of 3, that's equal to 8. And I wrote the whole thing out for the first two, but 2 to the 4 is 16. 2 to the 5 is 32. 2 to the 6, 64. 128. And you notice we're just doubling each time for 2's. The powers of 2 come up the most because they're the easiest to do with our mental method. Once we get to 3, 3 squared is 9. 3 cubed is 27. And 3 to the 4 is 81. That's probably most likely how high they'd ask you to go for mental math. I'll add one more in green. I think you could probably still get that one with mental math. But I don't think they'd ask you 3 to the 6. I mean, the more of these numbers you know, it is helpful for mental math. Okay, 4. 4 squared, you know, is 16. 4 cubed is 64. I don't think you'll be having to recognize 4 to the 4 is 256 without a calculator, but you would need 4 cubed is 64. 5 squared is 25. 5 cubed is 125. 5 to the 4 is 625. I don't think they'd expect that. And then once you get to 6, 6 squared is 36. But 216 is probably as far as you would ask to go. 6 cubed probably wouldn't ask you without a calculator. Same thing with 7 squared is 49, but 7 cubed, 343, I don't think they'd ask you. 8 squared is 64. 9 squared is 81. And you can probably guess that they wouldn't ask you for 8 cubed or 9 cubed. But this powers chart is very powerful. It's going to help you a lot in the questions that we're about to do. So for example, in A here, we want to write cube roots as a mixed radical. And if we're doing cube roots, we're going to be looking for our powers of 3. So I go to my exponent column of 3, and I'm looking at 8, 27, 64, 125. Because those are things I can cube root nicely. If you have the cube root of 27, it's 3. If you have the cube root of 125, it's 5. And that becomes important when simplifying radicals, because here it's dividing, so I can split it up according to the rules of dividing. I could do this. And I want to find out if 16 gets divided by anything in this column. And if you have the column, there's not very many numbers to check. There's only one number less than 16. Does 16 divide by 8? Yes. So I'm going to put an 8 in here, and in fact I'm also going to put the negative. Because in a cube root, if we can pull out a negative, we're going to pull out a negative. This would leave me with cube root of 8 times cube root of 2. Now 135. We have to see if that divides by a nice cube root. Well, which ones do we have to check? We only have 4 of them to check. And I hope you can already see that 125 doesn't multiply nicely by 2 to get to 135, so I can already take 125 out. 64 times 2 is 128, so it's not going to be that. 27. 27 times 5 is 135. So the powers chart lets you know that there's not that many numbers you have to check. But we found one that works. And the reason we find the numbers that work is because this allows us to simplify. Cube root of negative 8 is negative 2, and I would still have the cube root of 2 all over it. Cube root of 27 is nicely 3, and I would still have the cube root of 5. Jacket, binders, water. And now we could write this, put them back together. This would be like a fraction of negative 2/3. And I could write this now as 1 big cube root of 2 over 5. So when writing as a mixed radical, we are looking in our powers chart to see if there's numbers that we could pull out. So you don't even have to say, oh, should I try to divide this by 15? No, don't bother trying to divide it by 15, because 15 isn't a helpful number in this situation. We only had, from our powers chart and our perfect cube, a couple numbers that we would like to try, right? Square roots are the ones that, okay, square roots have the most possibilities, right? These are all the numbers you would want to try. But even there's not that many. And if you ever got a 4th root question, it's either going to be 16 or 81 for mental math. They won't ask you to divide by anything bigger than that. Probably it would be 16. They'd feel that 81 might be too hard for you. But if they did 81, probably the number that would come up inside the 4th root would be 162. 81 times 2. So knowing your powers chart really makes your mental math a lot easier, because you're not checking hundreds of numbers to make it simple. You're only checking a few. Now on the other direction, in part B here, I'm going to erase part A. Writing as a mixed radical, well, we want to change writing as an entire radical, we want to change that 3 to a 4th root. And the negative has to stay out in front, because for even numbers, even indices, you can't have a negative inside. Just like you can't square root a negative, you're not allowed to 4th root a negative, 6th root a negative, 8th root a negative, 10th root a negative, any of those. So the negative still has to stay out, but I want to change my 3 to a 4th root. Again, in my powers chart, I'm like, oh, 3 to the 4 is 81. So I can change the 3 to a 4th root of 81. And I'm multiplying, so this means I can multiply 81 times 2, because how do you multiply fractions? You multiply the tops, you multiply the bottoms. And 81 divided by 27 works out perfectly to be 3. So I get negative the 4th root, 3 times 2 is just 6. So circle question 3, 4, 7, and 8